Hello. So next we take up another two roller numerical which are placed into a trough, that is nothing but a container. Both the rollers are identical, so they have their radius given as 25 units radius, and because they are identical, the weights are 500 newtons. They are placed in a trough as shown. So find the reactions at all the or at various points of contact. So I have the point of contacts 1, 2, 3 and 4. Between the two rollers, we know it is always going to be compression. Now to begin with, for this particular example, at this point of contact 1, I will have a reaction which is R1 at 90 degree. At 2, I will have a reaction R2 which is at right angle 90 degree. At 3, I will have a reaction which is at right angles to the given, so it is 90. Coming to between these two forces, it is going to be like this, and I know it is compression, so two arrows outwards. I need to find the angle made by this force with the horizontal. This is a different kind of example. So now we know that the radius over here is 25 units and the base is 90 units. What will we do is we will extend this line, join the line from the center of the two rollers, and I will try to drop a perpendicular here down, so this forms a triangle. If I am able to get this angle, then it solves the problem. So how do we find this angle? Basic trigonometric functions that we know is sine and cos. If I am applying sine opposite by hypotenuse, I do not know this particular height. Probably in the figure it is looking exactly like a diagram or like a radius, but then when we draw it to the scale it might not, so this we are not sure of. I know the hypotenuse is nothing but 2 times the radius, this radius plus this radius, that is going to give me 25 plus 25, that makes it 50 units. Coming to the base, look at the base. So when I look or focus on the base, I know that this total is 90 and this is one part of the radius, this is another part of the radius. So if I'm drawing lines below, so this is 25, this is 25. So in between I will have 40 units. So the base of the triangle is going to be 40 because this is one of the radius, this is one of the radius. So 90 minus 25 minus 25 gives me 40. So we will basically have a triangle which is like this. Its base is 40 units and its hypotenuse side is 2 times of the radius, that is this 25 plus this 25, making it 50. So now for us to get the theta is of not much concern because theta is cos inverse of adjacent by hypotenuse side. That makes it theta to be cos inverse of 4 by 5, giving me the value of 36.86. Okay. So the angle here is 36.86. Now we have to draw the free body diagram like we did it in the previous case. So draw the two rollers individually as they are given and add some distances. These are the center points of the rollers. So first I will show the weight. I know the weights are 500 Newton. The second roller also is 500 Newton. Here for this I have a R1 which is horizontal. So I will show R1 to this end. Always it is better or easier to show all the forces that are going outwards. So I have a R1, this force. Then for this roller I have a R2 which is going up. So let us show R2. This is R2. And then we have this reaction that is between the two rollers, R4. For this roller it is coming in this way, for this roller it is going in this way. So I will show it like this, which is R4, and here this which is R4. Now we found the angle here theta, which was 36.86. So if I draw a horizontal like this, this is 36.86 and this is 36.86. Okay, so for this roller I have 1, 2, 3, 4 forces already done. 1, 2, 3, 4. Coming to this second roller, I have its weight, I have R4 and I have a R3. So I have its weight, I have R4 and R3. I will show it like this, which is horizontal in nature. So done with both the rollers. Let us call this roller 1. I'll call this roller 2. Clear with the free body diagram. Now this case becomes like a previous example, same example after drawing. The only change in this numerical is to find the angle between the two rollers. There is a reaction between the two rollers, therefore I had to find the angle theta. Different kind, wherein I knew the base, I know the radius, so I will find its angle. So once we are done with this, so what is the thumb rule? We will take up a roller which has got least number of forces, that is roller 2, which has got only 3, because it becomes easier to apply Lami's theorem. So I'll say first let us consider roller 2 applying Lami's theorem. Okay, so what is the Lami's theorem? Again, I'll just repeat once. It is the ratio of the magnitude of one force to the sine of the angle between the other two forces. So let us apply the Lami's theorem now for the roller 2. So R4 divided by sine of 90, R3 divided by sine of 90 plus 36, and 500 divided by this angle, that is sine of 180 minus 36. So just make a note of it. So that is R4 divided by sine of 90 degrees equal to 500 divided by sine of 180 minus 36.86 equal to R3 divided by sine of 90 plus 36.86. Want to repeat? It is R4 divided by this angle, that is 90, 500 divided by this, that is 180 minus 36, R3 divided by this entire angle, which is 90 plus 36.86. So on solving this, I'll have R4 divided by 1, which is equal to 500 divided by sine of 143.14, and R3 divided by sine of 126.86. So on solving, that is, I'll equate this with this, and once I'll equate this equation with this equation, I'll get the unknowns of R3, which is 666.9, and R4, which is around 833.52 newtons. So we get the two values here, that is R4 and R3, the two values. Please solve all of you and see that you get the same answer. So in this roller, now we are done with these two unknowns. So I got the value of R4, which is 833.5. So here to this roller, R4 is going to be 833.5 now. Now we will go to roller 1. So roller 1, as there are 4 forces, I cannot apply Lami's theorem, and I have to go with the equations of equilibrium, that is summation f of y equal to 0 and summation f of x equal to 0. We have to apply these two. So I will first write for summation f of y equal to 0. Look, I have minus 500 plus R2 and a component of R4. I'll make a note of it. It is positive R2 minus 500 force downward, then R4 minus R4 minus R4 sine of 36.86 equal to 0. Okay, so on solving this, because we know that R4 is 833.5 newtons. So on substituting, I get the value of R2 to be 999.9. I take it approximately 1000 newtons. Only I had one unknown. R4 is known, only R2 is unknown. So we'll substitute in this, I'll get the value of R2. Now I'll apply summation f of x equal to 0. So summation f of x, I have R1 and R4 only. So R4 is known to me, R1 is unknown. So first let us write it as R1 minus R4 cos of 36.86 equal to 0. So R1 becomes R4 cos of 36.86. We know R4 is 833.52. Right? So on substituting, I get the value of R1, that is 666.90 newtons. Okay, so this is already known to us, so we are simply substituting. So look at this now. I have first draw the free body diagram, find the angle, start with this roller because it has got only 3 reactions, apply Lam's theorem, get the answers, then go to roller 1, apply the conditions of equilibrium and get the answer.